Thank you everyone for joining me today. My name is Rochelle Longval. And before we started, please join me in acknowledging the caretakers of this land, the Indigenous peoples and their ancestors, the traditional territories of the Blackfoot Confederacy, Siksika, Kainai, the Piikani, the Tsuut'ina Nation, Nakota Nations, and the Métis Nation. So today I'll be talking about increasing longevity and supply through geothermal wellbore maintenance. And we're going to dive into Lakeview as our case study. Now, before we do this, geothermal, we know it's a renewable, it's a sustainable energy source. And when we look at the rate of growth we're seeing in our energy industry, geothermal is going to be really critical to meet that energy supply that we need. And one thing, as we start drilling these geothermal wells, operators are going to find strategically as they look to increase their production, they're going to have two options. They're either going to have to drill new wells, and as geologists, we know this can be time consuming and expensive, or the other option is looking at the well bores they have and performing regular maintenance so that they can get the optimized production that they're looking for. So let's dive into the smallest town in Oregon, Lakeview, and let's take a look into how they've adapted a maintenance program for their town. So this little town, they are small but mighty. They have 3,000 residents, so it's rural Southern Oregon. And what's interesting with them, I mean, when you go there, there is no McDonald's. The closest one is within 2 hours. And I always use that as a judge to see, okay, what do we really got going on here? How far away are they from other cities and urban areas? For them, they're heating. So they've got electric heating as well as propane as two main types. But the other thing for some of the municipal buildings, they are harnessing the heat beneath their feet. So we can be proud of them for that. And they're drilling about 700 to 900 feet. That's where they're getting just over 70 degrees Celsius. So that's excellent for them and a great way that they can supplement their heating. So on the left, we have the famous Lindell diagram, and you can see where they sit with the heating and cooling of buildings. Their focus, of course, is on the heating side. And this is important because globally, a statistic from IRENA shows that 50% of all energy consumption goes towards heating and cooling residential buildings. The reason this is critical is, can we look at ways to use electricity for those more energy intensive purposes, and then use geothermal, low enthalpy, for heating, for cooling? And that's going to really help to balance out our energy systems. And their goal is actually to have 70% of heating demand in Lakeview offset through geothermal. They currently have 2 geothermal district energy systems. So this is a low-cost energy solution for this rural community. And this is where this whole discussion on heat is critical, because depending where you are, this really can be economic for you today. The Lakeview South Geothermal District heating system cost them $2.6 million. Now, to heat the handful of buildings that they are doing with the system, it would cost them $50,000 US per month. So over the winter season, that's $350,000 US. That's crazy. It's really difficult and has been a challenge for this community. So by doing this geothermal district heating system, which they drilled 14 years ago, the South system, they're able to pay this off within 7 years. And I know, coming from a small town myself, a third of the size of Lakeview, even just using electric heaters in my home to heat our bathroom is $400 a month. And if we want to bring propane in, the logistics are complicated, but it's very expensive. So for them, this truly is a low-cost energy solution. So here's the Lakeview community buildings that are supported. So with one touch of a button, they're able to provide heat to these buildings. They have 2 systems, as I mentioned, the Southern geothermal district heating system, and the northern. So the southern is what we'll be focusing on today. And this is where they have the preschool, elementary school, middle school, high school, dental office, their hospital, their emergency services station. And then that second system is really working hard to heat that correctional facility. This is an excellent schematic that Jacobs Engineering has put together just to show the South Geothermal Well. And what you can see here is that when they're producing their heat, they're getting 71 degrees Celsius to surface. From there, it goes through to the 3 different school buildings, so the elementary, middle, high school. And then it goes into the hospital as well as the emergency services station, through to the Head Start preschool building, and then to the dental clinic. And when they're re-injecting, it's at a temperature of 57 degrees Celsius. And right now, Jacobs is doing a lot of work on their reservoir modeling and actually helping them to determine how they can expand their system. So goethite scale. As they pulled their ESP about 1.5 years ago, it came up all black, all gunky, and they thought, what is this? And unfortunately, they took some samples, sent it off to find out what it was, and they had goethite scale build up in their wellbore. And this was huge for them because one of the challenges is drilling this 14 years ago and being municipal based, it's very common, you know, you drill it and it's going to be good forever, right? But not having that regular wellbore maintenance plan in place really became a challenge. And this past winter, you know, around September time, it just started to get cold. And all of a sudden, they didn't have the flow rate they needed to heat these buildings anymore. So what did they do? Well, they turned on that propane and the costs went up, and that's how they heated those buildings, unfortunately. But one thing that's a challenge is even one of the buildings, the preschool, they didn't have propane set up. So they actually said school's out, and it was out for 6 months. So all those preschool kids, their poor parents, I have a little preschooler, you know, it's a huge challenge, especially in these rural communities. You typically don't have the support system to just, let's set up another school. You know, these kids had to stay home. So for them, what they saw was when they look at their flow rates, they need 130 gallons per minute to be able to heat all those buildings that I showed you. 4 years ago, they actually started monitoring their rates. So that's important. And they were at 160 gallons per minute. And in the fall last year, they were sitting at 88 gallons per minute. So, you know, they had to get back to that 130. So what do they do next? Well, when we look at well field operations and maintenance, we've broken it up into 3 buckets, and these are all critical. So you have your preventative methods, you have your monitoring, and then you have your regular maintenance. And we're going to focus on maintenance today because when that emergency bell rings, which is really what happened for their community, that's where they keyed in their focus. So this can be conventional solutions like chemical, so acid flushing, bullheading, and then mechanical, so broaching, brushing, reaming, also known as milling, or an innovative method known as electrohydraulic pulse. So they had to look at the comparison of different methods, and there were some critical factors that came to mind. So starting with the conventional method, chemical, as you're probably aware, you know, we're dealing with calcium carbonates or easier scales to treat. Hydrochloric acid is a common method used. Once you deal with more difficult scale, like silica, you're having to throw hydrofluoric acid in. Then you're going to have even more corrosion issues, which is a challenge. For them, being that this well is right in their town, they got really nervous about using chemical solutions. There are a lot of health and safety risks, environmental risks that they had to be aware of. They also knew they're going to have to get additional permitting, which is dependent on where you are. They're going to have to truck in the chemicals from a far distance. And because it's not as effective, they're going to have to do more treatment methods. so more commonly. So those were all reasons they were thinking, maybe chemical's not the right fit for us. So then they went to mechanical and they said, okay, because it's a difficult scale to treat, we probably can't do brushing or broaching. We're going to have to bring in a rig. Well, the closest rig, Bakersfield, California, 10.5 hours away, you know, giving them a call, they wouldn't even answer the phone call. It's really challenging when you are in these rural environments trying to bring a rig out. First, you got to convince them, but the second, you better have deep pockets. And for these municipalities, it's just not there. The other challenge is if they did bring in a rig was just, are they going to accidentally drill out through the side of their wellbore? That's going to cause really increased costs to them. You do have a larger footprint. There is more health and safety, larger crew on site. So these were all things that they were considering. Also, within the wellbore, you want to be able to treat, your slotted liners. Mechanical solution just can't do that. You're not going to be able to clean out those slots. So that was another thing they had to really take into consideration. So that's where they came upon the innovative electrohydraulic pulse tool. And where this checked a lot of their boxes was they're going to have a lot less frequent treatments. This is because of how well it is able to clean the wellbore. You're not leaving that nucleation point where you're going to get more and more scale building up really fast. The other thing is it's rigless, so it's run on wire line. And you do get those immediate results. It's also a targeted approach, which is critical, low carbon footprint, eco-friendly solution. There's no chance of damaging the reservoir or the wellbore completion equipment, and a low risk for health and safety. So what is electrohydraulic pulse? Well, this is where you're able to remove flow impediments like scale in the near wellbore region. And the electrohydraulic pulse, it's actually converting a small amount of electricity at surface, so 1,000 joules, and creating a powerful electrohydraulic pulse downhole. So how does this work? Well, you'd go onto the well site, you'd unplug the coffee machine, but you'd make sure everyone's had their morning coffee first. And then you'd plug in the tool. And with that 1,000 joules to make your morning coffee, you'd be able to run the tool. That energy is going to go down into the charge unit where it's going to build up to 30,000 volts. It's going to be released into energy storage, the power amplifier, and then it gets to the electrode. And in the electrode, you're going to get a jump between the anode and the cathode, and it's going to create your spark. Once you create that spark, you're going to have a wave that propagates outwards into your wellbore. It'll hit your casing and reflect back. Now, this is really important. When that wave propagates, that's your compressional force. When it reflects back, that's your tensile force. The key thing about scale, all scale has a high compressional strength, but a low tensile strength. Meaning, as you're doing that push and pull to peel off the scale, that tensile force back is what's going to peel it off the sides of the wellbore, which is extremely effective. You can also think of it is that the high amount of energy is used to create lightning, which is your spark, but your thunder is actually the sound waves that are propagating. So you get these shock waves that are propagating at the speed of sound, and those shock waves, your thunder, which is a lower energy event, is what's going to be effective in peeling off the scale. So you can see here, just in the photos, you've got prior to treatment and after treatment. And what's key too is that the pulse is going to travel until it reflects off. So in the casing there's a whole bunch of divots due to corrosion. It's actually going to get into those divots and peel off that scale, which would be very different than if you were pouring chemicals or doing a mechanical treatment. You can also see that with the slotted liners. And as far as how many pulses can you do per run, so you can pulse 12,000 times per run. So this is going to get you 120 meters over a span of 8 minutes per meter. And this will just depend how difficult your scale is. If it's silica, you're going to double your pulses. If it's a calcium carbonate, you'll be doing less pulses. So one thing that was really neat with Lakeview is that they come with the goethite sample. And while 39 types of scale had been successfully treated to date, this was a new one. So we said, all right, send over your casing and let's actually pulse it and try it out on surface and see if we can clean this wellbore. We were pretty optimistic we could clean it, but we wanted to understand how many pulses we would need to get that clean. So we actually get to experience this together. Perfect.
So we've taken one of those samples and actually put it into a test tank where we actually have the tool itself connected, coming actually into the sample. And inside there is where the arc and the discharge will occur. And as we're pulsing, it's going to break away the items that are on the inside. And what we'll see is actually dirt and debris coming out the outside as that pulsing occurs.
So these are the pulses,
Hmm.
and they're happening every 5 seconds. And what
Oh, look at all that coming out so quick.
you can see, you can see the black coming out, right? So that's the goethite scale coming out each pulse. And so for the goethite scale, we actually ended up doing 60 pulses in the field. Here we just tested about a dozen.
You looked at it before. Whoa, that's pretty clean. Should have
Isn't
seen
that
it.
amazing?
Yes, it is.
Yeah, so happy to take you on that journey with us. So when we look at the Lakeview producer well, we're dealing with basalts, and what they had here is they had 3 main water-bearing zones, which you can see in the yellow stars. And as soon as we got to site and went to touch bottom, 624 feet is what we got to, and that's where we knew, okay, they actually have wellbore collapse at that point, which is really unfortunate. And that can happen, especially when you get corrosion and you're not having regular maintenance, but there's a lot of factors that can contribute. So as a result, 105 feet were pulsed over an 8-hour period, treating those top 2 water-bearing zones. And the results, so as I mentioned, 4 years ago, 160 gallons per minute. Now they're sitting at 88 gallons per minute. Once this treatment was complete, we actually hit over 300 gallons per minute, but once we plugged in all the buildings, it took us to our stable rate of 206 gallons per minute. So this was huge because we were able to successfully restore the heat to the community buildings, and it just so happened to be on Valentine's Day. So I brought my heart with me, but it was really valuable to bring the heat back to this community. Thank you so much, and happy to take questions.